Welcome to a journey through the cosmos, exploring the terrifying and magnificent scale of the universe's most extreme stellar objects. From the densest remnants of dead suns to titans that defy physics, we will witness the true monsters of space. We begin with a stellar black hole, technically no longer a star, but the final, catastrophic collapse of a gigantic one. With an event horizon often only 20 to 40 miles in diameter, these cosmic destroyers are actually terrifyingly small objects. Take Cygnus X1, for example. It would barely fit into a large metropolitan area, yet its gravity is absolutely inescapable. Not even light can escape them. They are dark points on the cosmic canvas around which everything else must revolve. When they feed on matter from a nearby star, they form an ultra-hot accretion disk that shines brighter than thousands of suns. Next is a neutron star. Slightly larger, but no less extreme, forming when the core of a massive star collapses. The immense pressure crushes protons and electrons into neutrons. With a diameter of only 12 miles, they fit inside a city. Yet they weigh more than our entire Sunday. A single teaspoon of their matter would weigh about 1 billion tons. They spin rapidly, often hundreds of times per second, and emit powerful radio beams that sweep across the galaxy like lighthouses. Now behold the magnetar, a rare and nightmarish type of neutron star possessing the strongest magnetic field in the known universe. Their magnetic fields are trillions of times stronger than Earth's. They are cosmic traps that defy our understanding of physics. If a magnetar passed Earth at the moon's distance, its magnetic force alone would wipe every credit card and distort atoms. These stars are prone to violent starquakes that unleash enormous bursts of gamma radiation capable of sterilizing nearby solar systems. We move to a white dwarf, the exposed core left behind when a star like our Sun eventually dies. Sirius B is a classic example. About the size of Earth, yet containing the mass of the Sun within it. Incredibly dense and intensely hot, but without active fusion. It slowly cools over billions of years into a dark ember. In binary systems, it can steal matter from a companion until it becomes unstable and detonates in a massive supernova. Next is a brown dwarf, often called a failed star. These objects sit on the line between gas giants and stars, roughly the size of Jupiter, but far more massive. They lack just enough mass to ignite sustainable hydrogen fusion. Instead, they glow faintly as they burn deuterium before slowly fading over eons. They are warm rather than intensely hot. Unlike true stars, they may even host complex clouds and violent weather systems in their upper atmospheres, behaving like planets. Now we see a red dwarf, the most common star type in the universe, making up about 75% of all stars. Proxima Centauri is one of them. Small and cool, they burn fuel so slowly they can live for trillions of years. Their lifespan is far longer than the current age of the universe. They will be the last lights in the cosmos. However, they are often volatile, unleashing powerful flares that make the development of life on nearby planets incredibly difficult. Enter the orange dwarf, the quiet middle ground between red dwarfs and stars like our Sun, offering a perfect balance. Slightly smaller and cooler than the Sun, yet far longer lived. They can shine steadily for up to 30 billion years. Many scientists consider them ideal candidates for hosting alien life due to their remarkable stability and extreme longevity. A yellow dwarf. Our Sun belongs to this class. A stable middle-aged star that fuses hydrogen into helium to create light. Yellow dwarfs live for about 10 to 12 billion years and serve as the standard by which other stars are measured. They are large enough to warm planets, but not so large as to destroy them with excessive radiation or gravity. Next is a white main sequence star, hotter, larger, and brighter than the Sunday stars like Sirius. A shine with brilliant light. They shine with a white light tinged with blue. Their higher temperature means they are consuming their fuel much faster. Because they burn fuel faster, they live much shorter lives, typically lasting only around 1 billion years before dying. A Wolf-Rayet star, an engine of pure violence. These stars are incredibly massive and are nearing the end of their lives. They burn so intensely that they blast their outer layers into space, creating powerful stellar winds and losing mass rapidly. Though not enormously large, they shine millions of times brighter than the sun, surrounded by glowing nebulae of their own making. A red giant, the aging phase of normal stars. When fuel runs low, stars swell into massive bloated spheres. They can reach up to 100 times the sun's radius. Their surfaces are cooler, giving them a distinct red hue, but their enormous size makes them extremely luminous. As they expand, many will consume their own inner planetary systems. A blue supergiant. Young, violent titans born from extremely massive stars. They are hotter and denser than red giants. They burn through fuel rapidly and explode in spectacular supernovae after only a few million years of existence. A red supergiant. When blue supergiants cool and expand, they become giants of unimaginable scale. Like the famous star Betelgeuse, they can reach 1,000 times the sun's radius, extending beyond the orbit of Jupiter. Their outer layers are incredibly thin. Glowing, hot, and tenuous, they pulsate as they approach collapse, preparing to end their lives in a cataclysmic explosion. A red hypergiant, the largest stars known to science, existing at the very edge of physical possibility. They are true monsters. They can reach over 2,000 times the sun's radius. Light takes hours just to cross from one side to the other. These stars lose massive amounts of material each year and are wildly unstable, shedding their mass in violent outbursts. A Thorn-Jitkow object, a bizarre and possibly rare hybrid, formed when a neutron star is swallowed by a red supergiant. Replacing its core, the neutron star lives inside. From the outside it looks normal, but inside it is powered by exotic physics. A quasi-star, a hypothetical monster from the early universe. Before heavy elements existed, gas clouds could grow to immense sizes. Their cores collapsed into black holes without destroying the surrounding star, powered not by fusion, but by a feeding black hole. These stars could grow thousands of times larger than the sun, rivaling the size of entire solar systems in diameter. Finally, a supermassive black hole, the largest structures formed from stellar matter. Objects like Ton 618 contain billions of solar masses. Their event horizons are so vast that light would take weeks to cross them. They are the anchors of galaxies. As quasars, they can outshine entire galaxies. They are the ultimate apex predators of the universe, consuming everything in reach. From the tiny, dense, city-sized neutron stars to the galaxy-sized monsters like Ton 618, the scale of the cosmos is humbling. This is where our sense of scale ends. The universe is far larger, stranger, and more terrifying than we can imagine. Thank you for watching. If you enjoyed this journey through the stars, please subscribe to Giang Mystery Hub for more. Explore more mysteries of the universe by clicking on one of the videos on your screen right now. Stay curious. The cosmos is waiting for us to uncover its secrets. Until next time, keep looking up at the stars above. This video was created with a passion for astronomy and science communication. We appreciate your support for our channel. Remember, every star you see in the night sky has a story, a life cycle, and a destiny of its own. Even the darkest black holes were once bright stars. The cycle of creation and destruction continues forever in the deep dark. Our journey today covered only a fraction of what exists out there. Somewhere out there, right now, a new star is being born, and another is collapsing into a black hole. We are part of this grand cosmic web, connected to these stars by the very atoms in our bodies. As Carl Sagan once said, we are made of star stuff. Understanding the stars is, in a way, understanding ourselves. Perhaps one day, humanity will travel to these stars and see these wonders with our own eyes, up close. From the city-sized crushers to the solar system-sized giants, the variety of stellar objects is truly mind-bending. And among them all, our humble yellow dwarf remains the most important to us, providing the energy for all life. It is a reminder of the delicate balance required for life to exist in such a violent and extreme universe. Next time you look up at the night sky, remember the monsters and the miracles that are burning up there. Gravity is the sculptor of the universe, shaping these stars and eventually crushing them into oblivion when they die. The death of a star is not just an end, but a beginning, spreading elements to create new worlds. The iron in your blood and the calcium in your bones were forged in the hearts of these giant stars. We are truly children of the stars, born from the ashes of ancient hypergiants and supernovae from eons ago. And at the other end of the scale, the supermassive black holes wait, the final resting place for all matter. It is a cycle of light and dark, matter and energy, playing out on a stage of infinite proportions. The study of these objects pushes the boundaries of human knowledge and challenges us to think bigger than ever before. Thanks to modern astronomy, we can now peer into the hearts of these stars and understand their deepest secrets. Billions of years from now, the universe will look very different, but these laws of physics will remain the same. The story of the stars is the story of everything. It is a narrative written in light across the void. We hope this video has sparked your imagination and given you a new perspective on our place in space. This has been a production of Giang Mystery Hub. We are dedicated to bringing you the best cosmic content. Don't forget to hit the like button if you learned something new, and share this video with fellow space enthusiasts. Which of these stellar monsters fascinated you the most? Let us know in the comment section down below. Thank you for watching Giang Mystery Hub. Until our next journey into the unknown, goodbye and keep wondering.